Okay, good afternoon, everyone. I'm Pamela from CropLife. I'm field scientist and coordinator of drone application and digital agriculture of CropLife Field Science Department in Asia Pacific. I'm also the application technology group leader of drone task force under CropLife Asia. And today, Chris Chi from Bayer, who is the agronomic solutions manager in Asia Pacific, will present this topic with me together. And it's great pleasure for us to work together to introduce best application practices of drone application. Here is today's outline for our topic. Firstly, we will briefly introduce market outlook in China. Then we will move to the advantages and challenges of drone application. After that, technology updates and progress will be introduced. Finally, Chris and I will introduce best application practices of drone application based on our research and experiences. First, let's see the China agriculture drone market overview. We know that China is the most advanced country in the world in terms of drone application. So you can see from the Ipsos data, by 2025, the agro drone total market value is estimated to be $2.25 billion US. There are several reasons drive this faster development of drone application in China. Urbanization, aging population, labor shortage and high cost, land consolidation, strong government support on drone application, strong needs to promote and improve agricultural sustainability of government and industry, and also dramatically dropping of service cost. For example, for China rural population quantity, it is dropped sharply by 21% over past 16 years and continue to drop at this rate. In terms of farm aging, farmers who spend more than 30 days per year in the field are older than 55 years old in China nowadays. And all of these reasons drive the rapid growth of drone application in China. So in last year, in 2020, the total treated air reached to 110 million hectares, and total numbers of drones in China reached to 67,000. And drones are mainly used for the application of pesticides, fertilizer, defoliants, fodder, bait, etc. And the top 4 key crops treated by drones are rice, wheat, corn, cotton, such row crops. And fertilizer and seed spreading increased dramatically since 2020, and fruit application will also be the next big opportunity on drone application in China. In terms of manufacturers, we know that DJI and XAG, the two companies dominate this market. For the market share by DJI, it is almost 60%, and for XAG, it is 22%. Similarly, this is, this is Ipsos data on rice drone application market. So based on this chart, you can also see that by 2025, the total treated acres are estimated to be around 55 million acres on rice in China. There are similar reasons drive this faster or exponential growth on rice, like multi-applications at different crop growth stages, like land consolidation, labor shortage, and increasing cost of production. Now let's talk about advantages and challenges of drone application. In terms of advantages, we know that it is labor, time, and water-saving technology with high efficiency. It is more convenient to be used on rice paddy, sloping field, and mountainous areas, and no destruction of soil structure and crop compared with the ground squares. It is safer to people and less exposure for the applicators. And it is proved good and comparable performance with backpack application so far in most cases. And related technology optimized and matured quickly day by day. Also related laws, regulations, standards are generated and developed day by day. There are also strong market investment and strong government support, and application by drone application extended from a simple pesticide application to broader area like spreading seeds and fertilizer. Contrary to the advantages of drone application, there are also challenges which limited the development of drone application. Firstly, risk management, especially drift management, is a big challenge. For example, in China, every year related crop safety cases or customer complaint happened. Next is unstable efficacy and crop safety performance, especially by techniques in using. Thirdly, in terms of service provider and operators, some of them, their professional knowledge and skill are relatively low. In terms of market, we know that in part of the market, it is disordered, like the price is low and unreasonable. The service quality is unstable. For example, some service providers, in order to gain more money, in order to improve work efficiency, they may sacrifice the service quality in order to gain more money and to get better work efficiency. Finally, related work policy laws and regulations making still fall behind the frequent upgrade of drones. Based on those challenges and advantages, we still can see some potential opportunities of drone application. And since drone application is a part of digital agriculture, we expected that digital agriculture will revolutionize current traditional agriculture, and a new digital technology mindset is spreading quickly among growers and will change their life and work style. Secondly, the development and upgrade of drones is much faster than some important R&D work and laws, regulations, standards, and training systems establishment and execution. So it is extremely important to keep the relevant work in step and to promote the healthy development of drone application. Thirdly, drone application have many advantages over backpack or manual applications, but good risk management and compliance with use recommendations are essential. It is very important. So specific BAP, best application practices generation for drones is a key to necessary guidance to growers and industrial. In terms of market, professional and systemic farmer service platform will develop quickly as a new business model. And we also can say that leveraging experiences and knowledge of China, Japan, and Korea would be a good choice. Among the 6 points, for the point 2, 3, and 4, I think that it is urgently needs collaborative and joint efforts of industrial research institutes and the government to push forward related work, and we do need to work together. Now I will give you a simple introduction of the technology progress and development trend. Firstly, for the drones, nowadays it is becoming more intelligent with higher efficiency by combining AI technology, better radar system, better camera system, etc. And in order to satisfy to the different customers' needs, the load capacity developed to 2 directions, smaller ones like T10 and bigger ones like P40 or P80 and T30 from XAG and DJI. Also, we can say that battery life, power consumption, charging system is continuous improvement. We can also observe the continuous improvement of positioning and obstacle avoidance system with the development and advancement of radar, RTK signal, 5G network, RTK base station camera. And drones are developed to developed and designed to adaptable to sloping field and fruit trees like T13 and EA 2021. We know that spreading system is developing rapidly, so we expect that spreading and fruit application will be the next market hotspot. Finally, precision application. This technology or this development direction or trend will be extended to all areas of agriculture. It will dominate future trend with the development of real-time image processing technology, variable rate application technology, data fusion technology, high precision RTK positioning technology, and multi-aircraft function technology, and UV spraying supporting technology, etc. And now, Chris and I will introduce best application practices of drone application based on Bayer and Corteva's research and experiences. Since 2016, technical feasibility was evaluated and confirmed on drone application for more than 70 products on disease, insect, and weed control, and also defoliant application on rice, wheat, corn, cotton, potato, and citrus. We proved that in most cases, all products showed very good technical feasibility by drone application on those crops based on almost 400 internal and external field efficacy trials, field crop safety studies, field deposition drift studies by cooperation with leading universities and research institutes. And no negative crop response was found in these trials for those products. Now I will hand over to Chris to let him introduce best application practices based on Bayer's experiences and studies. Chris, please.
Thank you very much, Pamela. And can you mute from? Thank you. So, hello everyone. I'm Chris from Bayer Crop Science, and I'm very glad today I can share some experiences regarding drone application, the experiences on behalf of Bayer Crop Science today. So let me start this introduction regarding this field trial methodology establishment. So we all know that drone is different from manual application. So before any field trial starts, we need to know that how big size of the field trial we need, because especially for APAC countries that there are many smallholder farmers, means that the field is limited. So with drone application, what would be the minimum plot size we can use to conduct the field trial is quite necessary before everything starts. So that is why we started this field trial methodology, I say this exploration. So basically, you can see normally now all the drones have some inhomogeneous application during the acceleration period and also the deceleration period. So it means that we can only get a very, say, homogeneous application during the even fly speed time. So by that objective, we designed a field trial with this frequently used method in China with this paper card, and to use this dye method to analyze the spray quality underneath the one fly path. So to measure how long would be the even speed length of one fly path. So this would be give us some information to further calculate what would be the minimum plot size we should have for one drone application plot. So can I move to the next slide? So after we have this trial that and also after doing some calculation and also some assumptions, we think that the minimum of a plot size should be, the plot length should be 20 meters long at least, and to get this sufficient valid assessment zone. Because when we assess after the application, when we assess the field performance, we need to get rid of the inhomogeneous application area and also the side area from the plot. And also we need to leave left enough space for the assessment. So that is why we think that at least this 20 meters length, as well as these 3 to 4 fly paths, are necessary in terms of the plot wise for one single zone plot. And our final recommendation would be this 320 square meter or 240 square meter for one zone plot, and we need 3 replications. But this is just based on our say our study and our assumptions. And some nowadays you can see is from other authorities, like from the proposal from China's authority, that they also proposing like having this big plot size of 1,000 square meter, but without replications. But more or less, you can see the total size of one zone plot is more or less the same. So that is our recommendation. And can move to the next slide. So after we have this suitable plot size, we need to consider what are the flight parameters we should have. So for one US application, there are so many flight parameters which will influence the spree quality, like spree size, wind speed, flying height, and like droplet size, a lot of these factors. So we need to establish the standardized and reliable flight parameters to get a suitable or very good spree quality. So in next slide, I will show you an example how we can reach that. So can I move to the next one? This is one example we had, or a study in situ. So basically we designed the trial also using the similar way, use this paper card and diameter to evaluate the spree quality. And we designed a different row space or the spree size, and different fly height and droplet size, and also water volume. By all these comparisons, we conclude that for citrus application, we might need a relatively, say, 1.52 meter above the plant. And also the spree size is a little bit narrower than the field crop. Say here, we took P20 and P30 from XAG. We think the row space would be, say, 2.5 to 3 meter or 3 to 3.5 meter, which is much narrower than the field crop. Normally, they will recommend 4 to 5 meters. And the fly speed would be, say, 1 to 4 meters per second, depending on what kind of water volume you're going to use. And also the droplet size, we recommend a smaller droplet size to reach a better spree quality. And you can also see that we are thinking that through this trial, we observed more than 70 liter per hectare the water volume. We will give you a very good, say spree quality. But this is just based on this XAG's US model. So if we change to other US model, maybe the parameters should be adjusted accordingly. So this is just one reference. So can we move to next slide? So after parameters, we know that as I also mentioned, the spree quality is very important, but sometimes we need to balance with this spree efficiency as well. So the most important factor is water volume. The more water volume we use, basically you can get a better spree quality in general. But at the same time, you will sacrifice your efficiency. So we need to balance to have the very good efficiency, but at the same time, we need a very good spree quality. So this water volume is one important factor when we're doing these field trials. So I will give you some examples in the following slide. So this is one regarding rice stem borer control. So you see that we have this different water volume sighting from 15 liter per hectare to 22.5 liter per hectare, and compared to manual application. So you can see clearly the efficacy increased when we're increasing the water volume. And this is a very quite common observation if you in other crops as well, if you have these similar trials. So basically for rice, we will recommend roughly from 15 to 20 liter per hectare's water volume to ensure the very suitable efficacy. And you can also see from the list that for different crops, because the canopy density is different, the suitable water volume recommendation will be also be different. And also even within one crop, depending on the different crop stage, maybe in earlier stage, in seedling stage, when the canopy is not that dense or big, we can recommend this relatively lower dose, but relative lower water volume. But later stage, we might need a higher water volume to reach this very good spray quality as well as efficacy. And move to the next slide. And besides water volume, we also mentioned that droplet size is very important. The reason that why UAS can have this also good efficacy even under very low spray water volume is because the droplet size is very small. So the smaller droplet size you have, the more droplet you can get. Means that even under this low water volume, you can still get very suitable droplet density and means the spray quality. But sometimes the too small droplet size will have this risk of drift and evaporation. So it not means that the smaller droplet you get better. So based on these conditions, we get this reference from the professors from university that the optimum droplet size of different target as shown in the left side of the chart. Like this disease control, they recommend to have this 30 to 150 micrometer. But in general, when we consider the drift, normally we will use this 100 to 150, even bigger droplet size. And when we operating the drones, you can see that they are mostly using different type of the nozzles, which we will also give you this different size of the droplet. And on the right side of the chart, give you a good indication of which kind of color of the nozzle will provide how big the droplet size. So normally it currently is used like this orange or orange or red color. This very fine droplets would be used to reach a very good spray quality. Okay, move to next. So they are also, after we considering all the previous say conditions, the plot size, the flight parameters, water volume, droplet size, all these parameters. After this, we can we have this field trial with all these suitable parameters. So these are following two examples. One is from rice disease control. Regarding all the 17 trials we had in APAC, different APAC country, you can see clearly the UAS efficacy is very comparable with manual application. And you can see also the variation for UAS application is much smaller. It means that because this is also another advantage from UAS, because manual application, normally different people will have this different spray quality, or sometimes they will be overlapping on inhomogeneous, but basically the UAS can give you a much more, say, more homogeneous application because it's totally automatic. So this is for rice disease control. So if you have to move to next is about the rice pest control, similarly the result. So the UAS is very comparable with manual application, can give a very good the efficacy on all of this mentioned rice pest mentioned in the slide. So I think that is all from my side. Some experience shared from Bayer, and I will give it back to Pamela to continue to share you some experience from Captiva.
Okay, thank you very much, Chris. And so as Chris mentioned, that drone application or UAS application showed very good performance. Now I'll give you some failure demonstrations to demonstrate a good performance of drone application. So you can see that this is a weed herbicide trial against weed control. So you can see that for drone application, it showed very good performance against weeds control, and which is comparable to backpack application under severe weeds infection. Similarly, you can find that very good field performance of rice fungicide akin to Wang against rice force smart control by drone application, which is comparable to knapsack application under severe disease infection. Similarly, very good performance was found for potato fungicide Zovac incantia against potato late blight control by drone application, which is comparable to knapsack application under severe disease pressure. We can also find very good field performance of corn insecticide spinetoram against corn fall armyworm control by drone application, and which showed very good and comparable performance with backpack application. So I just want to reiterate that all what we tested products showed very good technical feasibility by drone application, and it is comparable with backpack application in most cases, and no negative crop response was found. So based on those studies and experiences, we generated a BAP. This is an example of BAP on potato late blight control. We found that a very good potato late blight control fungicide, Zorvac Incantia, can show very good technical feasibility by drone application due to its superior performance and outstanding systemic activity. So following other recommended environment parameters, flying and equipment setup parameters. So you can see that for the feasible wind speed, it is not recommended to apply the fungicide when the wind speed is larger than 3 meters per second, and also avoid to apply when there's no wind too. And avoid to apply under low relative humidity and high temperatures because evaporation and drift is easily happened. And also avoid to apply under other non-favorable weather conditions, like when it is forecasted to be rain within 4 hours, and do not apply when air inversion may happen. For the water volume, it is similar to Chris' recommendations. Based on their studies, we recommended to use larger water volume, which is larger than 22.5 liters per hectare. And for the drone type, we recommended to use representative drones from DJI and XAJ. In terms of flying speed, flying height, swell speeds, we recommended to follow the direction for use from drone manufacturers, but use lower speed and narrower swell speeds. And for the flying height on potato, late blight control, we recommended to use under the range of 1.8 to 3 meters above the canopy. And for the flying mode, autonomous flying mode is preferred. And we know that in some mountainous areas or sloping field, autonomous flying mode may not easily realized. So in such case, M+ mode is secondly preferred or recommended. And also we strongly recommended to check your spray quality, that is meant to avoid a missing application for late blight control. And also to follow the correct tank mixing procedure, and the spring tank should be rinsed 3 times after application. And all the related application information should be properly recorded after application. And for the nozzles, we recommended to choose right nozzles by considering the pests, the late blight, the pest, the weather and flying parameters, and also the optimum biological droplet size, which is introduced by Chris just now. In terms of adjuvant for this product, it is no need to add additional adjuvant, generally speaking. But in case of extreme weather conditions, or in case you need to tank mixing using with other pesticides, in such circumstances, you may need to add some adjuvant. So this is an example of best application practices of potato late blight control fungicide. So that's all for our presentation. Thank you very much.